right, so these are going to be the notes for completing the square for day 1 and day 2. So right here it says completing the square is another method we use to solving quadratic functions. And it also deals with how to convert from standard form to vertex form. So the first thing it says is completing the square is adding a term to an expression x squared plus bx to make it a perfect square trinomial is called the process of completing the square. Now, right for this one right here, what we're going to do is we're going to look at it. X squared minus 16x plus 64 is equal to 100. And we're going to solve it by square roots. But the problem here is that in order to solve it by square roots, we can't have this standard form function. So if we leave the 100 alone, we can look at x squared minus 16x plus 64. And if you recall, it's one of those perfect square trinomials. So let me just give you one of them. It's a squared plus 2ab plus b squared, right? You can see this is a perfect square. So the square root of this is going to be a, and this is a perfect square. The square root of that is going to be b. And if you multiply them together, you get ab. And if you double it, you get 2ab. So if you remember, we use the middle symbol, plus, parentheses, and squared. So that's the shortcut. Now, if it were the other one, where it was just a minus sign, if that was the only difference. So a squared minus 2ab plus b squared. Again, we would do the same thing. Square root, multiply ab, double it, 2ab, use the middle symbol. So those are the two shortcuts that we're going to be using today. So x squared minus 16x plus 64. So when looking at that problem, if you go to factoring, you see that this is a perfect square, and so is this. So if we take the square root of x squared, we get x. The square root of 64 is 8. So if we multiply them, we get 8x. If we double it, we do get that 16. So we use the middle symbol. Parentheses squared is equal to 100. And by factoring the left side and setting it equal to this 100, now we're going to be able to solve by using the square roots. So remember, we do PEMDAS backwards. So first we look for any addition or subtraction that may be outside of the parentheses, which there's not. Then we look for multiplication or division. And that would be something in front being multiplied or something below being divided. And that, again, is not. So now we go to our exponent. So to remove a square, we take a square root. And don't forget to put plus or minus. On the left side, the square root and the square are going to cancel each other out. So that leaves us with x minus 8. And on the right side, the square root of 100 is 10, but don't forget your plus or minus. And it's not necessary to have these parentheses, so let me go ahead and erase those. All right, so now we have x minus 8 is equal to plus or minus 10. Now to isolate x, all we have to do is add 8 to both sides. And at this point, we get x is equal to 8 plus or minus 10. And once again, we can't just add the 8 directly to the 10 because the 10 is positive and the 10 is negative. So here you're going to see we have two solutions. So x equals 8 plus 10, which is 18, which is our first solution. And x equals 8 minus 10, which is negative 2, which is our second solution. Okay? Now, this process right here that we're going to do, completing the square, we're going to be able to get our ax squared, our bx, but we won't have this c value that's perfect, right? So the goal of today is to force this property right here, these two, to happen every single time. And that method is called completing the square. All right, so we'll kind of take a look at this right here. It says to complete the square for the expression. In each diagram, the combined area of the shaded region is x squared plus bx. Adding b divided by 2 squared completes the square in the second diagram. Okay, so I'm just going to kind of show you the process behind this. Okay, so our standard form is, like it said before, we just have x squared plus bx. Plus, now you'll notice there is no c value, right? They just said x squared plus bx. So we're going to find the perfect c value. And the formula to find that is actually this right here. This right here is going to be how you find your perfect C value. So it's going to be b divided by 2 squared, okay? And then when you factor this, if you take the square root of this, you get x. If you take the square root of this, you get b divided by 2. And then if you multiply them and double it, you do get that, which would be plus, and then we would square it. All right, so the square root of that is x, the square root of that is there, okay? Multiply them, you get bx divided by 2, and if you double it, the 2's cancel, so you get bx, which is the middle, okay? So the one formula that you need to take out of this, put a star by it, whatever you need to do, it is c equals b divided by 2 squared. You do need to know this formula. This is the formula to complete the square, and you'll see me use it through all these notes. All right, so for the first one, it says making a perfect square trinomial. Find the value of c that makes x squared plus 14x plus c a perfect square trinomial. Then write the expression as the square root of a binomial. So let me kind of show you how to do that. So again, first thing we're going to know is the formula is c equals b divided by 2 squared. So right here, here's our b value. So c equals b, which is 14, divided by 2 squared. So 14 divided by 2 is going to give us 7. And 7 squared is 49. Okay, and that right there is our perfect c value. So when we talk about our perfect square trinomial, that's going to be x squared plus 14x plus our c value, which we just came up with as 49. Now, the second part it says is then write the expression as the square of a binomial. So here's my square of a binomial. So again, since we're forcing this to be a perfect square, the shortcut of factoring will work, okay? So we can take the square root of this, which is going to give us x, the square root of 49, which is going to give us 7. And then we use the middle symbol, and it's going to be a plus. And I didn't verify it because I'm doing the perfect square, so I know if I take 7 times x, I get 7x, and if I double it, I do get that 14x, parentheses squared. And this is the answer you are looking for right there. And this is just a part of the process to get there. All right, and now for these ones right here, same thing, you're gonna find that perfect c value and then make it a perfect square trinomial and then get the square of a binomial. All right, so the first one, c equals b, which is gonna be 8 divided by 2 squared. So again, the formula is c equals b divided by 2 squared. Let's put that about right there. There you go. Okay, so b is 8 divided by 2 squared. So 8 divided by 2 is 4. 4 squared is 16. So my trinomial, and put a t for trinomial, is going to be x squared plus 8x plus 16. Okay, now for my square of a binomial, again, we're going to do the shortcut. The square root of x squared is x. The square root of 16 is 4. X times 4 is 4x. Double it, you do get 8x. So middle symbol, parentheses, squared. All right, for the next one, again, same process. Find the c value. C equals b divided by 2 squared. So -1 squared, which is +1. So you'll notice that the perfect c value is always positive, and the reason that happens is because we're squaring that division here, and it's always going to be positive. So my perfect square trinomial is going to be x squared minus 2x, and that's a +1. And then for the binomial, we take the square root of x squared and we get x. We take the square root of 1 and we get 1. 1 times x is x. Double it, you get 2x. So we'd use that middle symbol, parentheses, and squared. All right, and then for our last one, this one is a little bit different because the number is odd, okay? And we're not gonna want we're not gonna want decimals here, so we're gonna keep it as a fraction. So let me show you what I mean. So c equals, our b value is -9 divided by 2 squared. And I'm not gonna convert it to -4.5. What I'm gonna do is I'm gonna square each one individually. -9 squared is 81. 2 squared is 4. And that's going to be my perfect C value. So my trinomial is going to be x squared minus 9x plus 81 divided by 4. And then for my square of a binomial, square root of x squared is x. The square root of 81 over 4. So the square root of 81 is 9. And the square root of 4 is 2. And it's a fraction. So it converted back to its previous self. So right here, if you multiply it, you get 9x over 2. If you double it, you do get the 9x. So we take the middle symbol, parentheses, squared. All right, so that's how you complete the square. Now we're going to use this to help us to solve these types of problems, right? So when I'm using this method to solve, I only use this method when I have an a value that is 1 and this is an even number. If it's odd, it does become a little bit tougher. It is doable, but it's a lot easier if a is 1. But if it's not and you get a problem like that, you just have to kind of work it through. All right, so for this one here, let me kind of show you the steps that you need to take to solve this. So you'll notice first off that this is not factorable. Second, you'll see that this C value is not a perfect C value. So the first step we're going to take is we're going to move the C value to the other side. All right, so now we have x squared minus 10x plus a blank equals -7 plus a blank, okay? So the first step we do is move the C value to the other side, and we leave a blank, because in that blank, we're going to complete the square. So C equals, our B value is -10 divided by 2 squared. -10 divided by 2 is -5. -5 squared is 25. So this number 25 is what's going to go in both of these blanks. All right. So again, to recap, first we move the C value over. Then we put blanks and we complete the square. And now pay attention, because the 25 that I came up with, the perfect C value, has to be on both sides of the equation, right? Because if I don't, then the equation becomes unbalanced. If I were to just put 25 on one side, then the equation is not even the same. So you do have to put the 25 on both sides, or the perfect C value on both sides. Now on the left side, you're going to factor it. You're going to use the shortcut. The square root of x squared is x. The square root of 25 is 5, and once again, you can always verify it. X times 5 is 5x, double it, you get 10x, so use the middle sign, parentheses, squared. On the right side, you're just going to combine your like terms. -7 plus 25 is going to give me 18. All right, from here, we solve by square roots, so we do PEMDAS backwards. There is no addition or subtraction outside. There is no multiplication or division, so we go to our exponent. To get rid of a square, we take the square root. Don't forget to put plus or minus. So the square root and the square cancel out, leaving us with x minus 5 equals to plus or minus. Now the square root of 18, I'm actually going to simplify that real quick. So right here, we're going to take 18 and we're going to break it down. So the smallest prime number that goes into 18 is 2, and it goes 9 times. Smallest prime number that goes into 9 is 3 times, and 3 goes into itself once. So when I look to simplify this, I start with my radical. I see I have a pair of 3's, so that comes on the outside. And what I did not circle was a 2 and the 1, so 2 times 1 is 2, and that goes into the inside. All right, last step we're going to do to solve this is we're going to add the 5 to both sides. So then we come up with x equals 5 plus or minus 3 square root of 2. And once again, we cannot combine the 5 and the 3 because the 3 is connected to the square root of 2 by multiplication. So these are unlike terms. Now, previous problems, when I worked it out, so back right here, so the process is the same from here. But notice I got 2 separate answers. I got 18 and -2. Over here, I only get this answer here. Now, I could split it into 5 plus 3 radical 2, and x equals 5 minus 3 radical 2. Both ways of writing it would be acceptable. But again, I can't go any further because of that radical sign, and I can't simplify, so this is going to be my final answer. All right. Moving on to when a is not equal to 1. So when a is not equal to 1, it does change a little bit, but it's fairly simple. So let me kind of show you how you should do it. So first off, you're going to take the a value when you're solving, and regardless of what the a value is, you're going to divide everything by a, both sides of the equation. All right. Once you do that, you're going to see what it comes out simplified. So 3x squared divided by 3 is x squared. 12x divided by 3 is 4x. 15 divided by 3 is 5. And 0 divided by 3 is 0. Okay, and now we're going to start that process over by solving by completing the square. You could try to factor this, but it is not factorable. Okay, so what we're going to do here is first, again, step 1. And I guess let me write the steps over here. So step 1, move the c value over. Okay, so step 1, I'm going to move the c value to the other side of the equal sign. So now we come up with x squared plus 4x plus blank equals negative 5 plus blank. From here, step 2 is we're going to complete the square. So c equals, my b value is 4 divided by 2 squared. 4 divided by 2 is 2. 2 squared is 4, so that goes in both blanks. Step 3, factor the right side, simplify the left side. Okay, so when I look at the left side, sorry, I put that backwards. We're going to, we're going to factor the left. Let me go ahead and fix that real quick. We're going to factor the left side. And we're going to simplify the right side. Okay, so again, this is the perfect square trinomial. The square root of x squared is x. The square root of 4 is 2. 2 times x is 2x, double it, you get 4x, so use the middle symbol, parentheses, squared. On the right side, we're going to simplify it, so we just combine like terms. Negative 5 plus 4 is negative 1. All right, the next step is solve for x. Okay, now on this one here, again, PEMDAS backwards. No addition or subtraction on the outside of the parentheses. No multiplication or division. We do have a square, so we take the square root of both sides. Don't forget, when you take a square root, you need to put plus or minus. All right, then over here, we have x plus 2 equals plus or minus, and hopefully you recall from complex numbers that the square root of negative 1 is actually I. And the last step we're going to take to solve this is we're going to subtract the 2 to the other side to isolate the x. And our solution becomes x equals negative 2 plus or minus I. And again, I cannot combine these two because they are not like terms. Okay. So the only difference between example 3 and example 4 is if you're solving and you have an a value that's not 1, first thing you should do is divide by the a value. And then after that, move the c value over, complete the square, factor the left side, simplify the right side, and then solve for x using your methods to solving. All right, so we have 3 examples here, and obviously you can tell the numbering is a little bit off, but let's go ahead and go through these real quick. So first thing I look at when I'm solving these is I make sure the a value is 1. If it's not, then I need to divide it, but in this case it is. So I'm going to find the c value, or actually, sorry, I'm going to move the c value over, so subtract 8 from both sides. That gives me x squared minus 4x. We're going to put the plus blanks. All right, we're going to complete the square. So b divided by 2 squared. So negative 2 squared, which is 4. So the 4 just goes in the blanks. From here, we're going to factor the left side. So square root of x squared is x. Square root of 4 is 2. Multiply it, double it, you get 4x. So middle symbol, parentheses squared. On the right side, negative 8 plus 4 is negative 4. To get rid of the square, we take the square root. And then we get x minus 2 equals plus or minus. Now, once again, you see that negative? That's going to become an I. So let me write this off over here. So the negative becomes an I. And the square root of 4 is 2, so that becomes 2i. So plus or minus 2i. And then last, to solve for this, we add the 2 to the other side. And again, we cannot combine the 2 with the 2i because they're unlike terms. So x equals 2 plus or minus 2i, and this is my final answer. All right, let's take a look at the next problem, number 10 here. All right, so for this one, first off, we're going to divide everything by 4 because a is not 1. So we're going to divide everything by 4. So we get 4x squared divided by x squared by 4 is x squared. 32x divided by 4 is 8x. And negative 68 divided by 4 is going to be negative 1, 7. So negative 17. Let me just verify that real quick because I don't want to make a mistake on that. So we have 68 divided by 4, and it is negative 17. All right, so I wanted to verify that. Now, the thing about this one is it's actually already set up for you, right? The first step is, like, if it's a is not 1, you divide by a. Then you move the c value over. Well, the c value has already actually been moved over for us. So what we're going to do is we're going to add the blank because the first first step was already done. We're going to complete the square. So c equals b divided by 2 squared, which is 8. 8 divided by 2 is 4. 4 squared is 16. So we had 16 here, 16 here. We're going to factor the left. So the square root, middle symbol, squared. On the right side, when we simplify it, negative 17 plus 16 is negative 1. Then we solve it. No addition or subtraction outside the parentheses. No multiplication or division outside the parentheses. So to get rid of the square, we take the square root. Don't forget to put plus or minus. So the square root and the square cancel out, leaving us with x plus 4 is equal to plus or minus, and hopefully you said the square root of negative 1 is I. Last step we take to solve this is subtract the negative 4, or subtract 4 from both sides. So we isolate the x, and x equals negative 4 plus or minus I. And that's my final answer. I cannot combine them because they are unlike terms. All right, number 12, a little bit different. So it looks like the first step I actually need to do is distribute the 6x. So 6x times x is 6x squared. 6x times 2 is 12x, and it equals to negative 42. A value is not equal to 1, so I'm going to divide everything by a. So divide everything by 6. That gives me 6x squared divided by 6 is x squared. 12x divided by 6 is 2x. And negative 42 divided by 6 is negative 7. And once again, so the c value has already been moved over for me, so I'm going to add the blank to both sides. Now, if the c value was on the same side, I would move it over and then complete the square. So c equals 2 divided by 2 squared, which is 1 squared, which is 1. So on the left side, we are going to factor it. Square root of x squared is x. The square root of 1 is 1. Middle symbol, parentheses squared. And then over here, negative 7 plus 1 is negative 6. PEMDAS backwards, no addition or subtraction, no multiplication, division. So to get rid of the square, we square root it. And we put plus or minus. So square root and square root cancel out. X plus 1 equals plus or minus. We have a negative sign. Make it a positive. Bring an I in the outside. 6 cannot actually be simplified as a radical, so we're going to leave it as the square root of 6. And the last step we're going to take to isolate x to solve it is, whoops, subtract 1 from both sides. Sorry about that. And then last but not least, x equals -1 plus or minus I radical 6. And this is my final answer there. All right, and that's how you solve. By completing the square. Now this would be it for the day 1 notes, but I'm gonna kind of go ahead and finish the day 2 notes along with this because it's fairly short. So another thing you need to know how to do is to complete the square to write it in vertex form. Okay. So when we're writing it in vertex form, we have to recall what the equation is. So the equation for vertex form is y equals a x minus h squared plus k. All right. So we already know what a is, right? We know that a is in front of x squared. So in this case, we already know that a is 1. Then we're going to have to figure out the vertex, and we know the x value of the vertex is h, and the y value is k. Okay. So here's how we're going to do this. So we're going to pretty much work it out like we do when we're solving, except there's a one step that's a little bit different. So when working this out, first thing we're going to do is we're going to keep everything the same, but just like the first step, we're going to move the c value over. So we're going to subtract 18 from both sides. And that's going to give me y minus 18 is equal to x squared minus 12x. And this we're going to add the plus blank now. That's why I left the space there. So the steps are the same, right? Move the c value over. Find your perfect c value. So b is right here, negative 12x. So negative 12 divided by 2 squared, which is negative 6 squared, which is 36. All right. This one's a little bit different because the left side I'm going to simplify and the right side I factor, but it's really the same thing. So on this left side, negative 18 plus 36 is going to be positive 18. On the right side, we factor it. The square root of x squared is x. Square root of 36 is 6. Multiply it, 6x. Double it is 12x, so use the middle symbol. Parentheses squared. Now, this is going to be the only difference from solving. So here, there's still a y, right? There's no actual just constant by itself. So to put it into vertex form, we're going to subtract the 18 back over to the other side. And our equation for our vertex form is y equals, parentheses, x minus 6 squared minus 18. So this is my vertex form. Now, the good thing about this form, honestly, is with standard form, without doing any math, the only thing I can actually know is that the y-intercept is 0, 18. And maybe that the a value is 1 and it's positive, so the graph opens up. But with the vertex form, once we convert it from standard to vertex, we can see that our parabola is going to go right 6 and down 18. We can see that the vertex, which is what they're asking us to find, remember, h, so the opposite of this is positive 6. And negative 18 is our k value. So we identified our vertex. But other things we can also get the axis symmetry, x equals h, so x equals 6. We talked about the transformations, right 6 and down 18. And we know the a value is a positive 1. So there it doesn't do anything, it just opens up. So you can see a lot more information from vertex form. All right, so for 13, 14, and 15, it's the same thing where you're just going to put it into vertex form. So I will do number 13 here real quick. I'll see if I can complete these all. So we're going to subtract 18, so we're moving the c value over. So we get y minus 18, and we know we're going to add the blank, x squared minus 8x plus the blank. From here, we're going to complete the square. So our b value is negative 8 divided by 2 squared, which is negative 4 squared, which is 16. So on the left side, negative 18 plus 16 is negative 2, so y minus 2. On the right side, we square root x squared, which is x. We square root of 16 is 4. middle symbol, parentheses, and squared. And last, to put it in vertex form, we just move this -2 back over by adding it. And then we get y equals, parentheses, x minus 4 squared plus 2. So that is my vertex form. And it asks you to identify the vertex. So the vertex opposite of that is h, which is 4. And k is positive 2. So there's my vertex form and my vertex. All right, for number 14. So the first thing we do is in standard form. C value is not perfect, so we move the c value over by subtracting it to the side of y. So we get y minus 4 plus blank equals x squared plus 6x plus blank. To complete the square, c equals b divided by 2 squared. So we get 3 squared, which is 9. So on the right side, -4 plus 9 is positive 5, so y plus 5. On the right side, we factor it. Square root of x squared is x. Square root of 9 is 3. Middle symbol plus parentheses squared. Last step to put it in vertex form is we move that 5 back over. So our vertex form becomes y equals, parentheses, x plus 3. It should be squared. I'm not sure why I put a 3 there. Sorry about that. And then minus 5. So there is my vertex form. And for my vertex, opposite of 3 is -3. Parentheses, k is -5. All right, on to number 15 here. So our last one for this part here, first thing we're gonna do, again, standard form, perfect c value is not there, so we're gonna make it happen. So we're gonna go ahead and, let's add the 6 over to the side of y. So we get y plus 6 plus blank equals x squared minus 2x plus the blank. So to find the perfect c value, c equals b divided by 2 squared. So -1 squared is positive 1. On the right side, we can see that 6 plus 1 is 7. And on the left side, 6 plus 1 is 7. On the right side, square root of x squared is x. Square root of 1 is 1. Use the middle symbol and square it. So the last thing to solve for y, we subtract the 7 back over. So our vertex form is going to be y equals x minus 1 squared minus 7. My vertex is going to be opposite of -1 is 1, comma, -7. All right, so that's how you convert from standard to vertex form. So we have one last problem, and this is a modeling one. It says the height, y, and feet of a baseball t seconds after it's hit can be modeled by this function here. Find the maximum height on the baseball. How long does the ball take to hit the ground? Okay, so for this one, a little bit different because our a value is actually 1, or is -16. So I'm going to show you how to do this. So find the maximum height of the baseball, which we know is the y value of the vertex. And how long does the ball take to hit the ground? That's an x-intercept. Okay, so for this one here, so to find the maximum height, all right, so we're going to convert this to vertex form. So the first thing we do is, let me write this right here, y equals -16 t squared plus 96t plus 3. So we're going to follow that same process. The first thing we do is we subtract 3 from both sides. So we get y minus 3 plus blank equals -16t squared plus 96t plus blank. All right, so this one's a little bit different. Let me kind of show you why. First off, the a value, we can't, when we're doing vertex form, we can't just divide it. Solving, you can, but when you're converting it to vertex form with an a value not equal to 1, you're going to actually factor out that a value, right? So in this case, we're going to factor out -16, okay? So -16 times t squared is -16t squared. -16 times, let's see, -6 is going to be 96t plus blank. Okay. All right, so on the left side, it actually changes things now. Instead of y minus 3 plus blank, it becomes y minus 3. And instead of plus blank, it's actually negative 16 times that blank, right? Because we have to balance it out. If I distribute this, negative 16 times t squared is negative 16t squared. Negative 16 times negative 6t is positive 96t. So this perfect c value is going to be negative 16 times whatever this value becomes in there. Okay, so that's why you're doing negative 16 times the blank and negative 16 times the blank. All right, so for this one, here's our b value. So c equals b, which is negative 6 divided by 2 squared. So negative 3 squared is 9. So on the left side, let me just put this in my calculator real quick. So we have negative 3 minus 16 times 9 is 144. So y minus 147 equals negative 16 parentheses square root of t squared is t. The square root of 9 is 3. Middle symbol is minus and square. All right. So now to put it into our vertex form, we're just going to move this 147 over by adding it. And then my vertex form becomes y equals negative 16 parentheses t minus 3 squared plus 147. So there's my equation. Again, let me just write it up here so it's a little bit nicer. All right. So from here, it does say find the maximum height of the baseball. So if I'm looking at the vertex, h is, if this is t minus 3 squared, this becomes a positive 3, and my k value is going to be 147. So the max height is right here. So the max height for the baseball is going to be 147, and I'm pretty sure this is in feet. Yeah, in feet. So there is the max height of the baseball, 147 feet. And then it asks, how long does it take for it to hit the ground? So this question is a little bit different. You're going to have to find the x-intercepts, roots, zeros, or the actual solutions, right? So we're going to take this equation we came up with, negative 16 t minus 3 squared plus 147. And we're going to just set it equal to 0, and we're going to solve it for x. So first I'm going to subtract 147 from both sides. So we get negative 16 t minus 3 squared is equal to negative 147. Divide both sides by negative 16. So we get parentheses t minus 3 squared is equal to negative divided by negative is positive. So 147 over 16. Now I'm going to keep it as a fraction because when I do my final answer in the calculator, then I'll make it a decimal. To get rid of the square, we square root both sides. So we get t minus 3 equals plus or minus, right? Because every time we take a square root, we have to remember to put plus or minus. The square root of 147 over 16. And then last, to solve this, we add 3 to both sides. And we come up with t equals 3 plus or minus the square root of 147 over 16. All right, now we only have one answer here. So let me get a scientific calculator so I can just work this out real quick. Okay, so to solve this, I'm just going to put in my calculator. So 3 plus, so second square root. I'm going to do second n over d to make a fraction. So we have 147 over 6. Hit enter. And you get 7.949. Let's go back up here. Let's hit enter again, and let's change this to a minus now. You could have just typed it in as well. Oh, okay, so let me clear this because I did make one mistake here. It should have been 16, not 6. So 16, there we go. Enter, so we get 6.03. This one, we'll change it to a minus. You can always just retype it. I'm just trying to make it as fast as possible here. And we get negative 0.03. Since this is real life, we know we're looking for the positive answer. So this is how long does it take for the ball to hit the ground? This is time. So we're going to say it's approximately 6.03 seconds. Let's make that a little bit nicer. 6.03 seconds for it to hit the ground. All right, and that concludes the notes for completing the square.